I would just mention one more thing. I think this is probably the number one lesson learned that I've had since working on the Orion project. It's the importance of full-scale testing. We in our test program, we had a number of tests where we failed. We call it a minimum system test, for example, where maybe we flew with we purposefully didn't deploy one of the main parachutes. So we came down under 2 main parachutes, which is in our requirement space. And we did this, the first time we did it, everything looked pretty normal. The second time we did it, we started to see this motion between the vehicle and the parachutes where it kind of looked like a pendulum that was swinging back and forth. But it didn't look very pronounced, and so we didn't really think that much about it. But then we tested that a third time with just a 2-main system, and it really got into this big, huge swing. And in looking at that, we realized that that's not a good situation where the Orion vehicle is meant to land, splash down into the water at a certain angle, at a certain velocity. And if you're swinging back and forth like you're a pendulum, you just don't know where you're going to hit, what angle, what speed, those sorts of things. But the important thing there is that if we had only tested that one time, we would have never have seen that mode of flight. And because of that, because we saw that, we were able to work with the program, work with the structures team, work with the guidance, navigation, and control team, and then work ourselves within the parachute team to try to come up with solutions that, we're ultimately successful, especially because of the work with the structures and the GN&C teams. So we found that as long as you have 3 parachutes, your likelihood of getting into that pendulum motion is very small. But if you get into the 2-main pendulum, if you get into a 2-main situation, then that's when it looks like that pendulous motion is relatively likely. But what the guidance, navigation, and control team has done is they've come up with, they call it a pendulum observer, where they basically realize that they've with the sensors that they have on board and the software, they essentially realize that they're in this pendulum motion, and then they essentially ignore it and don't try to correct for it and try to align and still align so that they're lining up with the wind vector so that they still land in a good configuration. It doesn't totally solve the problem, but it gets it within the risk levels that are adequate.